Here's our second video, the actual video I'm supposed to do today, which you're going to do tomorrow in class, along with the one I just recorded. This is still section 4.4, and there's just some miscellaneous items. Your homework is 69, 72, 73, 74, 94, 97 through 99. So what I'm going to do is I'm going to just do one of the problems that are like 69 and 72. I'm just going to kind of work through it, especially since I'm not going to be there in class. It says in the directions, find f as a function of x and evaluate it at x equals 2, x equals 5, and x equals 8. So in number 67, you are given this function. And I'm supposed to evaluate this f function for 2, 5, and 8. Please notice that these are both x's. So I'm going to go ahead and evaluate at x equals 2, which means find f of 2, which means I'm going to put 2 in for x. Now I'm just going to go ahead and proceed to integrate. T squared over 2 minus 5t from 2 to 0, and I get negative 8. They asked me to evaluate x equals 5. And I know this might seem like a very simple thing, but this is all over the AP Calculus FRQ questions. Some multiple choice, but a lot of the FRQ questions. So you're supposed to evaluate f of 5. Well, I'm going to go back up at the top what they gave me, and I'm going to, if they want me to evaluate this, that means I'm going to use what they gave me, and I'm going to put 5 in for x, and I can go ahead and I can evaluate this. So let's just go ahead and integrate it again. It's the same function, 1/2 t squared minus 5t. I went ahead and substituted immediately because I just looked up here. I put in 5 this time for the t's, right? And then I still put in 0, which is still just minus nothing. So it's 25 over 2 minus 25, which is negative 25 over 2, because I have to change that to times it by 2 over 2, that's a negative 50, and a positive 25, that's a negative 25 over 2. Done. Again, same thing if I have to evaluate it, x equals 8. Use what they gave us, so since they want me to find this, and that was given, I'm just going to go ahead and put 8 in for this and continue to proceed. And I get a negative 8. Next. You have homework problems 73 and 74. You are given a graph to look at, a graph for number 73 and a graph for number 74, and they're going to ask you, 5, 6, 7, 8 questions. I proceeded to just address one of the questions, which covers almost half of them. So in 73, they're going to give me this. G of x equals the integration from 0 to x of f of t dt, and they're going to give me some picture here. And that picture is of f. This function is f. So in one of the parts, they asked me to estimate g of 2. Please notice this. So that means they want me to do this. Right, just substitute in the 2 and the 2. But what is this? I mean, I don't even have a function. I just have a cute little picture. Is an integration area underneath the curve from 0 to 2? So basically they want me to find, no wonder they say the word estimate. Right? So that's area under the curve that's trapped between the vertical lines x equals 0, x equals 2, the x-axis, and underneath the curve, which is the function. And so I didn't put all the grid on here, but 1, 2, 3, 4, 5, 6, 7. You literally count underneath the curve. Another tidbit is number 94. I am not going to go into this problem. I again just want to address what they gave you in this problem. They gave you this. And again, I just proceeded to say it up here, but in that problem, hint, it's area underneath the curve. They give you a picture for this one too, and they ask you all kinds of questions. They ask you to fill out a table. Just remember that this is area underneath the curve from 0 to whatever it is, like up here, from 0 to 1, or 0 to 2, or 0 to 3, or 0 to 4. Got to find the area underneath the curve. The last piece that I'm going to address, which is again all over the AP test, and you'll see more of that as we do many of them, beginning with Thanksgiving break. You will have one. The position function, they give you in number 97. So this is, position, velocity and acceleration. So here's my position function from 0 to 5, including 0 to 5. And they asked me to find the total distance that this particle traveled from 0 to 5 seconds. And to find total distance means this. It is the velocity equation. So again, I could have written it like this. And it's the integration of the velocity equation, the absolute value. So in other words, if I had myself a cute little velocity picture, it meant that the area here is positive, but also the area that's typically negative, we're going to call it positive. So if this area was a positive 8 and this area was a negative 6, and they ask you to find the total distance from here to here, it would equal 14. Right? That's what it means pictorially. We've done some pictorially. And so another way to write velocity is x prime of t. Right? You take that first derivative, that's the same thing as velocity. So let me turn this around, and this is not a fun problem. Not a fun problem. So first thing we need to go and do is find the first derivative of this. Right? Bring down the 3, bring down the 2, use the 9. That constant becomes a 0, right? Next thing I want to do is I'm going to put it into my integration with the absolute value. I need to go ahead and also factor it because of what pieces are underneath the curve. I need to find out where it goes to 0, right? I set that equal to 0. And so it's going to happen at 3 and at 1. And so this is a parabola that opens upward, right? A parabola that opens upward. So we know it opens upward. So this is positive, this is negative, and this is positive. So now I know that I need to break this all up. Oops. So don't worry about this. I was writing on something. I need to break this all up. So I took out my 3. Now I can remove my absolute value because I've got my picture. I'm going to break it up. And so from 0 to 1, took out my 3. I have this part of the function, dt. And then I want to switch this. This right now, if I did this, would be negative. And so I want to change it to positive by putting a minus out front. I need to put the 3 here. The 3 is in front of each one of these because that function goes in front of each one of these. And this goes from 1 to 3. I'm going to flip that sign. Here it's going to be negative. I put a minus to make it positive. It's going to flip it up. And then the balance from 3 to 5. Again, I forgot my 3. So now I'm going to proceed on a second piece of paper where I've done all the math. Again, I'm doing this because I'm not going to be there. So I went back and I just took it from its factored form. I can't integrate it that way. I went back and I multiplied it back together. Again, that 3 is factored out. And so now, I know these functions are all the same, but let's go ahead and let's integrate. And so I took out my 3. I went ahead and did my integration from 1 to 0, minus, took out my 3. There's my integration from 1 to 3, plus 3, did my integration from 3 to 5. Okay, now I'm going to continue. So now, let me lift this up a little bit higher. I put in the 1 for everything, and then the 0 it goes to 0. So all I did is put in the 1. So this minus is this minus. Now I'm going to leave the 3 on the outside. There it is. There's my square brackets. Put 3 into this. Minus, I'm going to put 1 into this. There's my plus. Now I'm going to put 5 in. That's 125, because 5 cubed is 125. Minus, I'm going to put 3 in. And it's just a matter of very, very careful mathematics. If you notice, I had to write over my own writing and cross some things out. I had some difficulty myself. And so this is 1 1/3, which is 4/3. This is a positive 18 and negative 18, that is a 0. Minus, again, there's that 4/3. Here's that plus. And then I went ahead and just like distributed the 3 to everything inside of here. Makes it 125, negative 150, positive 45. And then minus, isn't that 0? There's that 0. That's 4. That's negative 3 times negative 4/3. That's a positive 4. And then I copied the rest down. And then I have 125 and 45, which is 170. It's 178. That's a negative 150. I get a positive 28. Thank you. There's one more video coming.